Hello friends, I'm gonna show you how to design footing in SAFE 2014 using the support reactions from STAAD file. Let's start. Let me open the SAFE. It's getting opened and go for File, New Model. Open SAFE, New Model and choose Design Codes and Preferences and Units as per what you are going to design. I'm changing the unit to metrics, which is comfortable for me, and the design code I'm going to design using Indian code IS 456 2000. Next, design preferences. You can see there the design code, the minimum covers for slabs, minimum cover for beams, etc., which we have to give. And you can change this according to your design. Everything and click OK. Then this is project information. Here you can provide those information, and this information will be shown in the report document. Okay, now since I'm going to import the points from STAAD, so I choose a blank page. I'm clicking a blank. This is how it is getting opened. Now let me go to edit and interactive database editing. Go to edit, interactive database editing. This you can do using Ctrl E button, and you make sure this is ticked. Exposure all input tables. Expose all input tables and go to geometry data, point coordinates. You tick that and click OK. A table will be getting opened. You can see this, and this is the point, first one. Second is coordinate x, coordinates y, coordinate z, and special point and guide. Now let me open the stat file, for which I am going to design the footing. This file I am going to open, and for this model I am going to design the footing in SAFE. These are all the points, these are all the columns, and these are all the footing points. And I'm going to select those footing around, and you select object only, and for example I'm choosing only these 6 points. The same procedure you can do for all the other points, and go for geometry. Here in right side you will get the coordinates of those points. Just Ctrl C and open an Excel file, a blank Excel sheet, and paste it. Here the first point will be the first column node and x direction coordinates, y coordinates and z coordinates. That is node number, x, y and z coordinates. Then the most important thing is, in STAAD plan means x and z direction. You can see this. Whereas in safe, plan means x and y direction. You can see x and y direction plan, which means we need to interchange these x and y coordinates. This is also applicable for data. I'm just interchanging these x and y coordinates here. Now I'm going to copy those points, those values, Control C, and open save, like edit interactive database, editing, geometrical data, point coordinates. I'm going to paste us. In special, you have to give S. This is due to when, even though if the points are not connected to the model, it won't get deleted. If it is no, the point will get deleted if it is not connected to any other points. So it is. Then this guide is nothing but this is for our reference. We can give specify any text from which we taken this and apply to model. Click apply to model. Done. As the points are created, but it is invisible. So make sure that go to the and tick this invisible and label. Okay, now the points are visible with the node numbers, same as the STAAD. Now you can go for post processing. Take the basic loads alone and select those 6 points and go for report. And support reactions. The loading, select only the primary load cases. You can give the combination safe and OK. So we will get the load. So just control copy all those and paste in an Excel. So you have to do some exercise. The same as coordinates you have to interchange. And you see this is node number, and this 1, 2, 3, 4 are load combinations. We have to check it in this STAAD. That 1 is dead load, 2 is live load, 3 is window X direction, 4 is window Z direction. So I'm changing it here. Dead, live, wind X, and wind Z. I'm copying this for all the other nodes. Now we have to copy this node numbers also for all the load cases before copying it to safe. Now I'm going to interchange the Z and Y axis. The moments also I need to, since in my case the moments are all 0, even though I am interchanging for your reference. Now what we have to define the material. first one is for tendon, which is not applicable in this case. Second it is for rebar, that is reinforcement. You can see here material type is rebar. Then I'm using FE 500. You can use you can give whatever FE 550 or 415 which you are designing. In my case I'm giving FE 500 and changing, and the material name I'm giving as FE 500. Okay, next one is concrete property. Material type is concrete. Here I'm giving a strength as 30 M30. I'm changing the material name as M30. Okay. Next one is define slab property. Modify. I'm giving this is as footing. Since the footing is designed as slab, I'm giving as footing 1. Material is M30. Okay. This is concrete, and for thickness I'm giving 300 mm. Okay. Next one is soil subgrade property. This is the important one. I'm modifying soil type 1. This is subgrade modulus. We have subgrade modulus is nothing but SPC divided by maximum permissible settlement. In my case I'm taking SBC as 500 and maximum permissible settlement as 25 mm. So I get 20,000 kN per m cube. Subgrade modulus, which is the same, I'm giving it as 20,000. Okay. Next I'm going to create the footing points, that is corner 4 points of the footing, and I'm taking my footing size as 1.2 meter, that is 4 feet. So I'm creating, this is the center point, so I'm creating all 4 corners. I'm creating a node. I'm just replicating all those things. Edit, replicate, and you can see this plus and minus I'm giving. For y direction, upward is plus, downward is minus. For x direction, right side is plus, left side is minus. Okay, now all the points are created, all the edges of the footing. I'm just removing that label to avoid confusion. Now it is clear. Now I'm going to draw a slab. We're going to draw rectangular slab area. Selecting the footing slab type error, footing 1 property which we assigned, and I'm just drawing the slab. For irregular slabs, you can use the other option. Now the slabs are created. I'm selecting all the slabs and assigning soil property, that is support data, soil property, soil 1. Okay, now the soil property is assigned. Now let me go to edit interactive database and tick this expose to go to assignment, load assignment, point load. You will get one table here. Point load for fx, fy, fz, which is other than f gravity, mx, my, mz. You already created. I am just changing. We already have the values fx, fy, and fz also is given as f gravity, and mx, my, mz, and here there is x dimension and y dimension whose unit is or in so x dimension, y dimension, this is none other than size of the column for each footing. In my case, the size of the column is 300 so I am giving 300 square column. I am just copying and pasting for all the other nodes, and you can select all those points, copy and paste here. Sorry, I have done a mistake. I'll just undo and paste it. Okay, now apply to model. Some error it shows. What I think is I have to assign the wind load. Wind load is not applied. You can see only dead and live is applied. Before that we have to define the wind load. I'm going for define load pattern. You can see there are only two loads. You have to define the wind load. By default they have only two loads, dead and live. So I'm adding load pattern. Should change it as wind type. This type will be useful when you give auto load combinations. Wind load X and wind load Z. Sulfate is 0 for wind load. Okay. Now you go for entity database. Same load assignment. I am deleting the previous record. Select and click delete record. Now I again copying and pasting it here. Now applying to the model. Okay, now everything is applied. You can check here by show loads. I'm changing the view 3D and select that show loads. You can select okay. So okay, dead load is applied. Live load is also applied. Wind load X direction is applied. Wind load Z direction is also applied. Now I am going for define load combination. You can add your combination by yourself, or you can click auto load. I am leaving strength and serviceability condition both. Strength ultimate and serviceability initial, normal and long term, and click OK. So loads combinations are created now. So I have to draw the design strip. Draw design strip. Here you can give the start with the same width as the footing. As my footing is 1.2, you can give 1.2. Your footing width. and selecting the strip layer as A. I'm going to draw at the center of the footing, all the footing in same direction. A layer should be in same direction to avoid confusion. Now I am changing the B layer. I'm drawing since mine is square footing, I need not change the start width and end width. It is 1.2 on both sides. Now the design strip is drawn. Now we can run the model. I need to save it before it get designed. I'm giving as lecture 1 and saving it. Now it's run and you can see the displacement, the maximum displacement is 4.25 mm. The displacement of each footing you can identify here using the colors, and you can check the strip forces by clicking this. You can choose the load, primary load, or you can choose the load combination for which you want the movement. Apply. Okay, so you get the movement, and you can change the layer to B, and you can also check the other direction, that is in B layer. You can also check the shear force in all the layers. Now you can check the slab design. So slab design, here layer A, and you take typical uniform reinforcement specified below, and I am choosing 8 mm bar at 200 mm center to center. So it doesn't show any red, that is, it says that this reinforcement is sufficient, no more reinforcement required. I'm checking for other layer. I'm checking for 250 spacing, but you have to tick that impose minimum reinforcement. So it shows the reinforcement is not sufficient. I'm changing to 200 and checking. Even though the reinforcement is not sufficient, I have to change the spacing. I'm changing it as 8 at 150. No, it's not sufficient. It showed some bottom and top reinforcement still required. The other direction also it says some reinforcement required. So I'm changing the dia as 12 dia, applying, and it shows it is okay. I'm changing it 10 dia. Oh, it shows little more reinforcement. Okay, I am going to change the spacing as 125. Apply, close. Okay, this reinforcement is sufficient. We can check it in other layer also. Yeah, okay, 10 at 125 is sufficient. Now we can check the punching shear. Show punching shear design. It shows 0.0923. Okay, it does. All the footings are safe against punching shear since the values are less than 1. The same way you can do for your isolated combined and also for raft footing. Thanks for watching the video. For more videos, subscribe Civil Spartans by Gopi, and thank you.